Okay, special angles. So we're going to start with a 45, 45, 90 degree triangle. That's an isosceles, right isosceles triangle. We know the two sides are the same. The sides opposite the 45 degree angles are the same. We're going to make them 1 and 1. So we need to determine the length of the hypotenuse, which is, let's call it x. So what's x equal to? Now, since it's a length, we're just writing this as x equals root 2, right? Not plus or minus root 2. We're not solving an equation here, right? We're finding a length, so it's just a positive. So x is equal to root 2. Use the dimensions of the triangle to state the exact value of each of the following. So sine 45 is what? What over what? 1 over root 2. But we don't like to leave radicals in the denominator, so we will rationalize it and end up with root 2 over 2. Cos 45 is? But we don't like to leave rationals in the denominator, so root 2 over 2. And tan 45 is? 1. So we now have exact values for 45 degrees, right? We know exactly what the sine of 45 degrees is, the cosine of 45 degrees, and the tangent of 45 degrees, right? So these are exact values, and you're responsible for knowing them. In a 30, 60, 90 triangle, so 30, 60, 90 is shown below. Determine the exact values of x and y. Hint, use the diagram below to the right.
Oh my gosh.
Okay, so how's this diagram going to help us? — 60, 60, 60. What kind of triangle? This side is? This side is? Right, because it's an equilateral triangle. And so, what's y now that we know x? Root 3, right? So this is 2. This side is root 3. Right? And we do that by, getting an equilateral triangle and then determining the side lengths. Okay, and again, we picked the 1 for a reason there, but in essence, it's arbitrary. We could have picked anything, but the ratio is going to come down to these ratios. No matter what if you made this 10 or 17.3, the ratios would still simplify. So, use the dimensions of the triangle. What is the sine of 30 degrees? Don't speak unless you can get it right. 1 over 2. What is the cosine of 30 degrees? Root 3 over 2. What is the tangent of 30 degrees? One over root 3, or root 3 over 3. What is the sine of 60 degrees? What is the cosine of 60 degrees? And what is the tangent of 60 degrees? Yeah, which we'll just call root 3. All right, so now, we now have the exact values for sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees. Okay? So these are the exact values. And so we can summarize this, right? The sine of 30 degrees is 1/2. The cosine of 30 degrees is root 3 over 2. The tangent of 30 degrees is The sine of 45 degrees is, the cosine is, and the tangent is, the sine of 60 degrees, the cosine, and the tangent. So you need to know these values, right, at some point. And that point is going to be reasonably safe. So we have these exact values, 30 degrees, 45 degrees, and 60 degrees. Since we have these values, we actually also know any multiple of 30 degrees, any multiple of 45, any multiple of 60, but we'll get to that in a few days. Okay, so we can now use this to solve problems, right? Which is determining exact values of each indicated sine, right? No longer are we going to use our calculator now, right? We're now going to use that table of exact values. So in relation to 30 degrees, what's the name of this side? What's the name of this side? What's the name? Really? Going to combine them? What's the name of this side? Okay, so how are we going to work out y? Okay, sine, so we're going to say the sine of 30 degrees is equal to y over 12, which means y is 12 times the sine of 30 degrees, which is 12 times 1/2, which is 6. Now, actually, your calculator would have given you that as well, right? Sine 30, cosine 60, they're both exactly 1/2, so. How are we going to get x? And use the cosine. We could use Pythagorean theorem, but let's stick with the trig here. Cosine of 30 degrees is x over 12. X is equal to 12 times the cosine of 30 degrees, which is 12 times, what's the cos of 30? Root 3 over 2. So 6 root 3. 6 root 3 bigger than 12 or smaller than 12? Smaller, has to be. How do we know that? It's not the hypotenuse, right? The hypotenuse is the longest sine, and that is not the hypotenuse, so it's not the longest sine. Questions on A? B. What's the name of y? What's the name of 15? What's the name of x? Okay, so which ratio are we going to use first? What are we going to solve for first? What do you want to solve for? X or y? X. Okay. So what are we going to what tan ratio are we going to use?
I don't know.
What trig ratio are we going to use? Right, so we know how to solve this, right? You're just going to interchange these two. What's tan 30? Root 3 over 3. Yeah, you know, it's also what? It's also 1 over root 3. Now, why might I want to use 1 over root 3? Because I'm going to flip it, and so this saves me a little operation, right? I won't have to divide stuff out. Okay, so it's 15 root 3. Right. Otherwise, what would you do 15 and you do it as root 3 over 3, which is 15 times 3 over root 3, right? And then you got to multiply by root 3. Too much work, right? Too much work. So just remember, root 3 over 3 is 1 over root 3, and root 2 over 2 is 1 over root 2, because if we have to divide by them, instead of dividing by root 2 over 2 or root 3 over 3, we'll divide by 1 over root 2 or 1 over root 3, which is nice, because then you're going to flip it and you don't have to rationalize. Okay, what else do we need? Y. What are we going to do for y? Sine. So we're going to say the sine of 30 degrees is y over 15. Thank you. I was waiting for that. So y is 15 divided by the sine of 30 degrees, which is 15 divided by a half, which is 30. I guess we can string equal signs. I only string them along because, you know, there's not much room there. So. Okay, y is 30. Yeah, I mean, we should be able to square 15 and square 15 root 3 and add them together and get 30, you know, square root 30, you know, 30 actually. Okay, x, y, and 45. So, what are the names of the sides? Opposite. And? Yeah, so always name the sides, right? Sides are always named in relation to a particular angle, which in this case is this one, because if we're using this 45, that's opposite, that's adjacent. So it doesn't matter though, right? Since the sine of 45 is equal to the cos of 45. It doesn't really matter which one you're using. Okay, so what are we going to find first? X. Okay, so what ratio are we going to use? Tan. So the tan of 45 degrees to find its opposite over adjacent, or x over 8. So x is equal to 8 times the tan of 45, which is 8. Now we kind of already know that since that's 45, and you know, but this shows a little use of trig, right? And then we got to work out y, which ratio y? Cos. So cos 45 degrees is adjacent over hypotenuse, 8 over y. Y is equal to 8 divided by cos 45. Yeah, we're going to use the 1 over root 2, right? Because we use root 2 over 2, then we have to rationalize the denominator. This way we don't, right? It just is what it is, which is 8 root 2. All right, so you just keep in mind, yeah, yes, it's root 2 over 2, but you know, it's easier to use 1 over root 2 here because that we won't have a rational radical in the denominator, which we then have to rationalize. Okay. If at any point you have any questions, ask. All right. So here now we're just solving for a particular value, right? We're not solving the whole. That bad? We can't just wait 5 minutes till we're done. You gotta go. Go. You gotta go. Go. Okay. What's the name of this side? Yeah. What's the name of this side? Sometimes it's best to always find the hypotenuse first, right? Especially when the 90 isn't where, you know, usually 90s are down here kind of thing. So when they're there, maybe we want to name hypotenuse first. Okay, which ratio are we going to use? Cosine. Now, what form of cos 45 are we going to use? Okay, remember, we're going for exact values here, right? So exact values means things are either expressed, they could just be a number, right? Like sine of 30 or cos of 60 when you're multiplying by a half or dividing by a half. You're not really going to do too much exciting. Or they're a number with a radical. Okay, so 10 root 2, which is less than 20. Okay, we got to solve for x. But first, what are we going to solve for?
The height.
The height, right? So we have two right triangles here, right? And we need to, there's not enough information in this triangle, right? I got 45 degrees, I need a side. So we're going to get that side by solving for h. We're going to do it with this. This is the hypotenuse. This is opposite. It's actually opposite the 45 and the 30, so that's kind of nice. I can just label it once. And this is adjacent. So which ratio are we going to use to solve for h? 10. So the tan of what?
30.
Okay, so tan of 30 is opposite over adjacent. So it's 15 times tan 30. What is the tan of 30? Root 3 over 3. Which in this case we want that form, right? Then we just H is 5 root 3. Okay, now what? What's this side? Okay, so which ratio? Sine of 45. If you wrote cos, I'm going to take a half mark off because well, you're still going to get the answer the same since sine and cos 45 are the same. But you know, if you want to write cos, then you know I don't know what you're going to do then, right? I mean, you then say, well, this is 45 here, so you're going to have to label this, and then you're going to have to label this as well. Okay, so if you want to use cosine, there better be some work there that justifies you using cosine, which is showing me the side opposite, or sorry, actually no, never mind. You'd have to label that as 45 degrees, right? Because then this becomes adjacent, and then you better put in adjacent there or something, okay? Because it should be sine 45 based on what we've got, right? If you want to use cos 45, nothing wrong with it, but then there needs to be some justification in the diagram to show that. Okay, so sine 45 is opposite, so that's 5 root 3 over hypotenuse, which is x. So x is equal to 5 root 3 over sine 45. Which form of sine 45 am I going to use? I'm going to use the 1 over root 2. So 5 root what? 6. Congratulations. You still can multiply radicals. It's good to see.
Oh my god.
Especially with the cume coming up. You know,
Oh no.
Some good practice on radicals here, right? I can rationalize denominators. I have to binomial denominators. We don't know if you can rationalize those, but we'll figure it out. Okay, good. Yep, moving on. The rear window wiper blade is 48 centimeters long. That just sort of comes out of nowhere, right? A car has a rear window wiper blade, but you know, really? The rear window wiper blade? The blade moves between an angle of 30 degrees and 135 degrees. I guess we'll assume that's an angle in standard position, perhaps, right?
Maybe it's a bearing.
Determine the exact, yeah, probably not. Determine the exact value of the horizontal distance that the tip of the blade moves in one swing.
Diagram.
Yeah, draw a diagram. Okay, so here's the blade, right? This is 48 centimeters long, moves between an angle of 30 degrees. I'm just drawing a standard position angle, right, of 30 degrees to a standard position angle of 135 degrees. Determine the exact value of the horizontal distance that the tip of the blade moves in one swing. So how are we going to figure that out?
Draw a triangle between draw a line.
Draw a line from where? Like a line how? A line here?
Yeah.
Yeah, I don't want
Do
to. Do a vertical line? So like here?
No. Yes. Oh yeah, that was.
Yeah. Okay. And how about one over here as well?
Oh my god.
Now that 135,
It's actually not 130.
yeah, it needs to be moved, right? Well, okay, then
You moved a line.
let's get rid of that. Yeah, I don't know if I can just move the. All right.
Oh, shoot, all at once.
Yeah, let's just redraw that.
Let's pretend that never happened.
Here's the window. 30 degrees. 135 degrees. 90. 90. 48. 48. And we're trying to find that distance there, right? Trying to find the horizontal distance that it moved, although really it shouldn't do that. So let's call that x. And let's call this y. And so, what do we got? 30 degrees. So we got a nice 30-degree triangle, right? So we can figure that out. Now, what's the angle in the other triangle? 45. Right? Because if that's 135 and the whole thing is 180, then that's 180 minus 135 or 45 degrees, right? Okay, so What are we going to say? How are we going to get x? Let's do the 30 degree first. What ratio would you like to use? Take your choice. Sine, cos, tan. You got a 1 in 3 chance of randomly guessing.
Tan!
Cos.
Oh, I got it.
So what's the cos of 30 degrees equal to?
My I always roll from.
Why do you always say it out loud? That's a more important question. What's the cos of 30 degrees equal to?
Root 3 over.
Which one's the hypotenuse? Okay, so what's cos 30 degrees equal to? What's cos of 30?
Yes.
Got one right.
Oh my god.
I know.
Hey, you told me.
Okay, how are we going to find y? Same thing? What, cos 30 degrees equals?
No, close 45.
Okay, cos 45 degrees is equal to? What?
Y over 48. Yes.
So y is equal to 48 cos 45. 48 times root 2 over 2. All right, so what is the exact value of the horizontal distance? Distance is what? 24 what? Yeah, I would just go 24 root 3 plus 24 root 2. Units?
Centimeters.
Centimeters. Yeah. I wouldn't factor the 24 out, right? You could, I wouldn't mark it wrong, whereas 24, 24 root 5, for sure I marked that wrong, right? But 24 bracket root 3 plus root 2, okay? 24 root 3 plus 24 root 2, sure. Don't forget the units though, right? Centimeters.
It looks like the.
Any questions? Yeah, that's a bracket.
No.
Wow, there's still more.
Oh my god.
How long does this keep going? Oh, that's the last part?
Yeah.
Okay. Express each of the following in terms of the reference angle and evaluate. So this is how you do other angles, right? So the cos of 120.
Is equal to.
So let's draw this out, right? We need to draw this out because you need to. I think you need to visualize. Well, I need to visualize. I don't know what you need. I need to visualize this.
I know we get it too.
Okay, it's 120 degrees. What's the reference angle?
60 degrees.
Okay. So here, theta r. So theta r is 60 degrees. Okay. That means that essentially we have a 60-degree triangle. Right? That's 60 degrees, and we're trying to figure out the cosine of 60 degrees. Well, we know that because it's in our table. But the all science teachers combust rule tells us what?
They all combust.
So it tells us which quadrant are we in with this 120 degrees? We're in quadrant 2. What's positive in quadrant 2? What's not positive in quadrant 2? Cosine. So we know the cos of 60 degrees is 1/2, but we're in quadrant 2, so it must be. There you go. So the cos of 120 degrees is equal to the negative cosine of 60 degrees. Right? So it's equal to the cos of the reference angle, but since it's in quadrant 2, where cosine is negative, then it's the negative of the cosine of 60 degrees, right? Or negative 1.
I mean,
I'll go outside.
oh my god, Ryan. Why did you do that? I don't want this so bad.
Okay, Sine of 240 degrees. Any questions, right? Everybody good? All right? So what we're using is this, right? In order to get the exact value of any multiple of 30, 45, or 60, we're going to use reference angles and the cast rule. I'm going to call it the cast rule because the ask rule doesn't flow trippingly off the tongue. 240, where's 240?
Where is this?
What's the reference angle? Nice try.
60.
If you don't get reference angles right, then you don't get questions right. Okay? The reference angle is the positive acute angle measured between the x-axis and the terminal arm. If that's 180 and that's 240, then I had to go 60. Right? Not just, hey, that's 270. Yeah, nobody cares. 90, 270, we don't care. 0, 180, 360, 180, 360, we care. Okay? If you want to do reference angles, it's 180. Right? It's how far do I have to go to get to 180? Go another 60. How far have I come past 180? 60. Or how far do I have to go to get to 360? Because this just is what it is, right? The angle is reference angle.
Oh, for the first one, like, why do we have cos negative again?
No, it's the negative cos of 60.
Yeah.
You do not see cos negative 60 here, right? Okay, good. It's like he operates 5 minutes behind all of us. Right? Like, seriously, what do you think about while we're doing this?
What is the report?
Where's your head? Okay. This is a quadrant 2 angle. In quadrant 2, which ratio is positive? Only the sine. That makes the cosine what? Negative. This triangle, this right triangle, has an angle of 60 degrees. Therefore, it is the cosine of 60 degrees, right? But it's in quadrant 2, so it's the negative cosine of 60 degrees. Okay? All right, what's he going to ask in 5 minutes? That's what I'm curious about.
Well, what happened right now?
Okay, yeah, exactly, right? So it's going to be, why is this negative? All right, so the sine of 240 degrees is equal to the sine of the reference angle, but it's in quadrant 3 where only what is positive? Therefore, the sine is negative. So this is the sine of 240 is equal to the negative sine of 60 degrees, which is negative root 3 over 2. Okay? You can verify this, right? I mean, you plug it into your calculator, make sure it's in degree mode, right? Which you have to change to now, right? Because you're going to be clearing calculators. You're going to walk in, you got to go mode degrees, right? And if you go sine of 240, it'll say negative 0.866, etc. Okay, tan of 135 degrees. Here is 135 degrees. What's my reference angle? 45 degrees. So we're going to say the tan of 135 degrees is equal to what?
Negative tan 45.
Negative tan of 45. Why is it negative? Because
Only sine.
only sine is positive. So if I was doing the sine of 135, I would say that's equal to the sine of 45, right? Okay, so that's equal to negative 1.
Oh my god.
Good. Keep going. The cosine of 225 degrees. Okay, theta is 225 degrees. What's theta r? 45 degrees. So what are we going to say about the cosine of 225?
Negative cos 45.
It's equal to negative cos 45, which is negative root 2 over 2, right?
Are you waiting for some?
What?
Were you waiting for some questions to like stats?
No. I'm just trying to finish before he gets a chance to ask. 330 degrees. Where's 330? Which quadrant? If only it were 330 now, right? We could just get out of here.
Yay!
But it's not.
Oh.
What's the reference angle? What are we going to say about the sine of 330?
Equal to negative
is negative 1/2, right? Okay, so the idea is we're using reference angles because basically we have a 30-degree triangle here, right? And in every 30-degree triangle, the sine of 30 degrees is 1/2, right? If we took this divided by this, it's 1/2. Okay, but we're in quadrant 4 where only is positive.
Combustion is positive.
Yeah, only combustion. Tan of 210.
Got it right.
Where's 210? Which quadrant? How far ended quadrant 3?
30.
Making my reference angle. So what are we going to say about the tan of 210? It's equal to the tan of 30, since we know that in quadrant 3, tan is positive. And what's the tan of 30? Root 3 over 3.
Oh, it's over 3.
Okay?
No,
Questions? Right? So draw a diagram, label it with the angle, determine the reference angle, or state the reference angle, I guess, or you're not going to show anywhere. State the reference angle. Use the cast rule to determine the polarity of the particular thing you're looking for, right? Is it positive or negative?
North.
Say that the sine of 330 is equal to, the positive or negative, in this case the negative sine of 30 degrees, and fill that in from your table. That's it, huh?
We get our table.